Right. Yeah, good morning, students. We were talking about dynamic memory allocation in a C language, and the functions used for performing dynamic memory allocation. We discussed in the last class. Quickly, we look at those functions once again. So the first function is Malloc function. This Malloc function allocates requested size of bytes and returns the pointer to the first byte of the allocated space. So if you want to allocate a block of memory, then we use this Malloc function. Then there is another function called calloc, allocates space for an array of elements. Okay, and initializes them to 0 and then returns a pointer to the first byte of the allocated space or the allocated memory, you can say. Always, whenever it is returning a pointer, that pointer is nothing but the address of the first byte only. Okay, so then free removes previously allocated space. When you allocate memory dynamically, you must remove the space. Okay, so that can be achieved by using this free function. Then realloc modifies the previously allocated space. If you allocated space using malloc or calloc, and if that space is not sufficient or too large, okay, so then you want to modify the size during execution of the program. Okay, so then that can be done by using the realloc function. Okay, so yesterday we talked about a malloc function, how a block of memory can be allocated. Okay, so that we discussed in the last class. Okay, so today an example also we have seen. When you say malloc 5 into size of int, okay, so then for 5 integers the memory is allocated as shown in the figure with the yellow diagram. Okay, then the first byte address 2004 is returned, and that you are storing in a p equals to int star. Int star is typecasting the void pointer into int pointer. Okay, so this we discussed in the last class. And for allocating a memory for storing characters, okay, so that can also be done. When you say malloc of 10 bytes of memory will be allocated, and you are typecasting it into char star. Okay, so storing in ptr, so 10 bytes of memory is allocated, and the first byte address will be stored in a ptr will be pointing to this block of memory. Okay, so all this happens when your program is executing. Please remember, memory allocation is two types. One is static memory allocation, second one is dynamic memory allocation. When you declare an array, the memory allocation will be static. Okay, so dynamically during execution of the program, if we want to allocate memory, then we use this malloc function. Okay, so first byte address will be stored in ptr, and ptr is now pointing to this block of memory, we can say. Okay, right. So once we know first byte address, we can calculate second, third, next byte addresses as usual. Okay, free is used for releasing the memory space, and the program also we have seen in the last class. Okay, so how memory allocation allocated successfully or failed, that also we can check if p is equals to null. Okay, so then we entered some integers and we stored those integers into this allocated memory, and using the for loop we checked this, and execution, program execution also we have seen in the last class. Okay, right. Now, this is only single block of memory we can allocate. Now, if we want to allocate multiple blocks of memory, then we need to use calloc function or calloc function. Okay, now see the difference. Malloc allocates a single block of storage space, whereas calloc or calloc allocates multiple blocks of storage, each of the same size. That means each block will be of a same size, and then sets all bytes to 0. So initializes all the bytes to 0. Calloc automatically initializes or stores 0 by default in the allocated memory, whereas malloc allocates block of storage and garbage value will present in that. Okay, so if you look at the syntax of calloc function, so then calloc, and within the parenthesis it takes two arguments, n comma element size. Okay, so here n is nothing but n blocks of memory I want to allocate. Each block is of size element size. Okay, so when this statement is executed, calloc allocates memory for n blocks, and each block is of size element size. Okay, then all bytes are initialized to 0, and a pointer to the first byte is returned that we are catching in, or we are storing in the variable ptr. Okay, so cast type means what type of numbers you want to store in that. Based on that, you typecast your void pointer into this. Also returns void pointer into that corresponding pointer. Okay, so typecast either into star or char star or float star, depending on the type of numbers you are going to store in this dynamic memory. Okay, so how it allocates memory diagrammatically we'll see here. For example, now I have declared a employee structure here for storing employee details. Okay, so what details I am going to store in that? Name, age, and salary. Name, age, and salary. I want to store these three details of an employee. Now I can store any number of employee details. Previously, when we said that if we want to store 3 members or 4 members employee details, then we would have declared an array there. Okay, but here based on number of employees, then we allocate memory dynamically here. Okay, so now see here. Then I declare a pointer here. I declare a pointer ptr here. Okay, so then I say n is equal to 3 here. Into n is equals to 3. That means I would like to store 3 employees details. Okay, so based on n value, then you can allocate the memory. Now you can allocate a memory for storing 3 employees details using this calloc function. Now see here, calloc. Okay, so within the parenthesis n is equal to 3 here. Okay, n comma, then what is the size of each block? The size of each block should be struct employee size. Okay, so each block size should be a structure size here. Okay, so that's why you give here size of is a single word here, size of struct employee size. Then it allocates memory for n blocks. Each block is of this struct employee type. And finally, because you are going to store employee structure data, so typecast this into struct employee star. Before calloc, you typecast this into struct employee star, and you store, it allocates memory for 3 blocks and returns a pointer that you are catching in ptr. Now see here, this ptr is of type struct employee type here. Struct employee type here. Okay, so I'll tell you the difference between previous employee structure and dynamic memory allocation structure. Now see here, when you have that structure and if you want to store 3 employees details, you would have declared like this, say struct employee. Okay, so 3 or 4 members, you do not know how many members, so that's why what we did, we declared a employee size of some 10 or 50 or 100, like this we declare. Okay, so if you declare an array of structures here, e of 10 here, so what happens? Memory will be allocated for storing 10 employees details like this. Okay, so this is e. Then this first one is e of 0. Okay, so this one is e of 1. Okay, and this one is e of 2. Like this 10 employees details. Again in this we have three fields, name, age, and salary, and each one contains name, age, and salary. Similarly here name, age, and salary. Name, age, and salary will be stored in each element. Okay, right? So here what is happening? This memory is allocated statically here. This is static memory allocation, e of 10. So for example, you want to store 50 elements, then e of 50 will say, but we may not have 50 elements data with us. Instead of that, now if you say dynamic memory allocation, what happens? Just see here. So if you, what we are doing is just we are declaring a pointer here, struct employee a pointer here, PTR we are declaring here. So what happens if for this pointer a memory is allocated? Only one pointer I am declaring. Okay, so then we are taking n value here. Okay, so if n is equal to 3, that means 3 employees details I want to store. Okay, so then what happens? Clr function allocates memory for 3 blocks. This is first employee detail, this is second employee detail, and this is third employee details. Okay, so like this 3 blocks, and here name, age, and salary. Name, age, and salary. Name, age, and salary. Okay, so this first one indicates name field, second one indicates age field, and this one indicates salary field here. Okay, so like this 3 blocks of memory is allocated, and this first block memory address will be returned here, and PTR now will be pointing to this first block, first byte address it is pointing. Okay, so if you have n is equal to 4, dynamically if you ask the user to enter using keyboard during execution of the program, so based on n value you enter, then the number of blocks of memory will be allocated. N is equal to 5, 5 blocks will be allocated. N is equal to 10, 10 blocks will be allocated. So here what is happening, based on number of employees we are allocating the memory. So here we are not wasting the memory. But whereas in first case you do not know how many employees, that's why you have to provide some bigger size here, because this memory allocation is fixed. Once you declare the size, the memory allocation is fixed here. So then 50 employees memory will be allocated, and you are using only 10 employees data. So what about remaining 40 employees memory goes waste. Okay, so that is the problem in static allocation. And if you allocate dynamically, then based on number of employees we can allocate the memory. Okay, now see here what happens. For 3 employees we are now n value we assumed that 3. I want to store now 3 employees. Only for 3 employees the memory is allocated like this. Now you can see the diagram here. Okay, so 3 blocks of memory will be allocated like this, and each block is of same size. Each block is of a same size. So the first field name field, then second one is age field, and next field is salary field, and all of them are initialized to 0 because name is a string. Here it initializes to empty string, white space it initializes. Clear? Okay, so once the memory is allocated for storing 3 employees details, now you can store details, each employee details in this way. Okay, now see here. So I am declaring a pointer here which is of type struct employee type. Okay, so you can access this memory block by using another pointer. Okay, so the first byte address always you must catch in some pointer PTR, and PTR should not be disturbed here. PTR should not be disturbed here. Okay, so you can access this by using another pointer. So what you are doing, you are declaring another pointer Q. I am declaring here. So then for Q also memory is allocated like this. Okay, now I say Q is equal to PTR. Q is equal to PTR. So what do you mean by Q is equal to PTR? Okay, so that means please point Q where PTR is pointing. That is the meaning. So PTR is pointing to this first two name field, no? So now Q also points to the same name field. Q also points to the name field. Nothing but the same address will be stored in this. I have not written any address values here. Okay, so the meaning you should understand at higher level. Q is equal to PTR means please point to the place where PTR is pointing. That is the meaning. So that means Q also now points to the first block of a memory now. Okay, so once you know the address of this first block or first field, now you can access these 3 blocks by using this pointer Q here. Okay, so now I can store values. Just see here how I can store. Now I am using a string copy function. So I want to store name here. How can I access this name field? Because Q is a pointer, you have to use structure pointer, you have to use arrow operator. Q points to name. Q points to name, comma, ABC. Okay, so because string, you cannot use assignment operator. So you have to use string copy function here. Okay, so string copy, Q points to name, comma, ABC. That means store ABC to the place where Q is pointing to name field. Okay, so in the name field, now ABC will be stored. Okay, and when you say q points to age is equals to 35. Okay, so q points to age means this one. Okay, so in age field 35 will be stored. 35 will be stored in age. Okay, so then q points to salary. Q is pointing to this entire block now. Please remember, q is pointing to this entire block. Now you can access, this block has 3 fields. You can access each field by saying q points to name, q points to age, q points to salary. Okay, so when you say q points to salary is equal to 1234.5, then in salary field you can see 1234.50 stored. Okay, now the first employee details we have stored in a first block. Now I have to move to the second block. How can I move to the second block? Just by saying q plus plus. When you say q plus plus, then it automatically goes to the next block. That is the advantage with the pointers. Okay, so it goes to the next block. Now q is pointing to the next block. Again, you can store values in this next block in the same way. Now you can say string copy q points to name is equal to xyz. Now q is pointing to second block. Okay, so in name field xyz will be stored here. When you say q points to age is equal to 45, in age field 45 will be stored in this way. Then salary is equal to 234. In salary field 234.75 will be stored like this. Okay, so now second block, that means second employee details I have stored. Now I want to move to the third block. How can I move to the third block? Just by saying q plus plus. When I say q plus plus, it goes to the next block. Okay, so internally the compiler knows how to calculate a q plus plus value. Q plus plus means it is not a by adding 1 here. When you are incrementing a pointer, scale factor will be used here. So scale factor here is nothing but size of the structure here. Okay, right? So again, you can store the third employee details in this third block. Okay, so q points to name means pqr will be stored. Q points to age is equal to 55 means 55 will be stored. Q points to salary is equal to 3045 means now 3045 will be stored in the salary. Okay, so once you store 3 employees details, now the question is we want to print again onto the screen. Okay, so again from the first employee we want to print onto the screen. So again you have to, when you say q plus plus, again it goes to the next space which is available after this third block. Okay, so you have to move this q again to the first block. So you make a q to point to the first block again. So how you can make a q to point to the first block again? Just by saying q is equal to ptr. See here, by saying q is equal to ptr, so again q moves to the first block because ptr is pointing to the first block now. So q also now points to the first block. Now using this for loop, now you can print the details. Just see here, q is equal to ptr. So q now points to the first block. Q less than ptr plus n you have to use here. PTR is something, some 1000 plus 3. Okay, so that means it calculates this address. 3 blocks you move. That is the meaning here. Okay, so name is equal to q points to name, age is equal to q points to age, salary is equal to q points to salary. That means first employee details will be stored here. Afterwards, then q plus plus will be executed. When you execute q plus plus, it goes to the next block, and similarly next employee details will be printed here. Q plus plus goes to the third block and the third employee details. This for loop repeats here. Okay, third employee details will be stored here. Then when you say q plus plus, it comes out from the third block and the condition becomes false. Okay, so then the control comes out from this loop, and on the screen you can see 3 employee details. Okay, right? So if you put everything in the program, now we'll see whether this works fine or not. Okay. Let me switch on the code blocks. Okay, right. So example, okay, so I'll copy this entire thing. We'll take an empty file. Okay, so here we'll copy here. So before that, we include the header files. When it comes to program, you have to fulfill all the formalities. Okay, so include the header file here. Similarly, we are using the string copy function, so that's why you need to include string.h header file. Okay, then you define the structure here. Okay, so structure you have defined here. Then here you define your main function. Okay, so int main you define here. Now inside the main, now you define a structure pointer. Okay, so then a variable enter n. This n even you can ask the user dynamically. Okay, so you can ask the user to enter how many employees details he wants. So just give you a printf message. Now we'll see here printf enter how many employees. How many employees. Okay, so because I have initialized there. Okay, so directly you can change these type of statements in your program. Okay, so let me initialize directly because already data is available with me. I'll show first. Afterwards, I'll make changes. I'll make this n value also dynamic afterwards. Okay, so then you create a allocate memory for these 3 employees now. Okay, so what I am doing, 3 employees data I want to store. Now first what I am doing is I am allocating memory for these 3 employees. Okay, so PTR is equal to struct employee alloc. Okay, right. Now the memory will be allocated here. Okay, so once you have memory allocated like this, the memory is allocated like this. Okay, so now we'll store details into this. So first what we need to do, we need to create a temporary pointer here. So I'm declaring a temporary pointer here, struct employee q, or if you don't want separate pointer here, so here you can declare star ptr comma q you can declare here. Okay, so then say q is equal to ptr. Now you allocated memory here. Okay, so now you can say q is equal to ptr. So now q is also pointing to that block of memory. Okay, so now using a for loop, you can copy these things. Okay, so these should be repeated for the 3 employees. No, so you can use a for loop here. So I am writing a for loop here for so you can say q is equals to p, or q is equals to p because you said q is equals to ptr here. Q is equals to ptr. This is not required, I think, because anyhow initialization will be done inside the for loop. No, so for q is equal to ptr, then q less than, you can say q less than ptr plus n. Okay, so that means 3 employees details you read q plus plus, we are saying. So here you need to ask the user through keyboard. Okay, so in example I have shown initialization directly here. Okay, so what we'll do is we'll read through scanf function. Okay, so scanf, otherwise because first employee details, no. right? So we can say scanf percentage yes, okay, comma. So way to store q points to name, okay. So then this should be in scanf function, scanf. So this is age, percentage d, comma, where to store in the address of q points to age, store in the address of q points to age, okay. So then this is salary field, no? So ask the user to enter scanf. This is percentage f, okay. So then say comma q points to salary, close, okay. So like this, for 3 employees details it will be asked here. Now you can make this n also dynamic here. Now you can ask the user to enter n value, how many employees now, okay. So we'll make the entire program as dynamic here now. So now you say enter how many employees, okay. Enter how many employees. So he entered some number 3 or 4 here. So scanf. Now you read a number of employees, percentage d, comma, store that in a n, address of n you store here, okay, right. Now for n employees we are allocating memory using calloc, okay. So then you ask the user here before for loop. Now you can say printf. Now you can give a message, enter name, age and salary of percentage d employees, because based on number of employees, if you enter 5 employees data, if you enter 10 employees data, he should enter. So that's why you have to use n value here dynamically. You cannot directly say here. So you clearly specify the order, name, age, salary of 3 employees. Percentage n value, if I enter 3, then you will get a name, enter name, age and salary of 3 employees on the screen. Now you enter those 3 details, and this for loop reads and stores in 3 blocks of memory. So here you should use ampersand symbol, because salary is floating point number. So if you want the same thing you want to follow, you can also use for string ampersand symbol, okay. So store name at address of name field, q points to name, and address of q points to age, address of q points to salary, okay. So this reads and stores as shown in the diagram, okay. So like this, the for loop reads data and stores 3 employees details like this, okay. So you can see, for example, you entered data. Now the 3 employees details will be stored in the memory in this form, okay. So once you have stored 3 employees details successfully, now we have to check out whether stored successfully or not, okay. So now we'll print each employee details here, okay. So printf. Now you can just print a message here, okay. So employees data, you can just print a message there. So what you are doing is you are printing employees data there, okay. So same for loop you can use. That means again you are, but instead of scanf here, now you can say printf percentage yes, but here this time you can say name is equals to percentage yes, comma, new line, okay. So say q points to name, and second one printf percentage d. What is this field? Age, okay. So age is equals to percentage d, new line, then say q points to age, okay. Then similarly now you can say and this is salary. Salary is equals to percentage F, comma, new line Q points to salary. So like this, from dynamic memory, now you can access 3 employees details, and that will be printed on the screen. Okay, so then you say return 0, close, then close the main function. Okay, so let me save the program. So what we give, we say it as clog. Okay, so clog dot c. Now this is how the program is. Please go through the program. I'll quickly explain about this program. See here. Okay, right? So first I am defining a structure here. Okay, so then inside the main I am declaring 2 pointers. One pointer for storing a address of the allocated memory, and Q is a temporary pointer for accessing that memory block here. Okay, so number of employees, I am asking the user to enter how many employees, because dynamic memory means employees details will be dynamic here. Okay, so then based on n value, now I am allocating memory for those many blocks employee. Okay, so n is equal to 3 means 3 blocks of memory will be allocated here. Then I'm asking the user to enter name, age, salary of 3 employees. Okay, so then this for loop reads and stores in those 3 blocks of memory. So first employee name, age, salary, second employee name, age, salary. Okay, so like this 3 employees details will be stored by using this for loop. Okay, then once you stored that, now you can access the data from dynamic memory, and you can print the data. So I'm printing the data, employees data. Okay, so using the same for loop, but this time printf you can use here. Name, age, salary of 3 employees we can print here. That's it. Okay, so save memory and save the file, build the file. Just check out there are no errors. If there are no errors, okay, then we can run the program. Now see, enter how many employees. Okay, so 3 employees will take, for example. Okay, so quickly we can enter name, age, and salary of 3 employees. Okay, so as we have seen from our example, okay, so first employee age, name is ABC, age is 35. Okay, so salary is 1, 2, 3, 4, 5 point something like 50. Okay, so then second employee details XYZ. Okay, so XYZ name, and his age is something like 40. Okay, so then his salary I am entering something here, something. Okay, so then third employee details is PQR. Okay, so assume his age is 45 and his salary is something some floating point number you enter here. Okay, so then you can see there employees data. Okay, so name is equal to ABC, age is equal to 35, salary is equal to 1234.50. Then second employee name is equal to XYZ, age is equal to 40, salary is equal to this, and the next name, age, salary. So 3 employees details it has printed. Now if you want employee 1 details, employee 2 details, employee 3 details, that way it has to be printed. Then that can also be done by using a variable I you can take until I becomes less than n value. Okay, so just you can go on printer. Clear? So that way also you can perform. If you want, you can use another variable. You can declare a variable here, because I you can declare here. Just see here. Okay, so you can use 2 initializations in point in Q is equal to PTR. Then I is equals to 1. You can say here. Okay, so condition is only one condition you should give here, and but 2 increments you can do here, Q plus plus and also I plus plus you can write. In for loop this is possible. 2 initialization, 2 variables initialization can be done. Okay, and 2 variables increment can be done here. Okay, so if you use this I is equal to 1 here, now you can see here, you can add another printf statement so that you will get the details. Now you can see here employee percentage D details. Then say new line, okay, comma I you can use here. Okay, so you will get a message employee 1 details. Okay, so name, age, salary will be printed. Afterwards Q++ will be done and also I++ will be done. Okay, so first time these two will be initialized. Q will be initialized to PTR, I will be initialized to 1 here. Then condition will be tested here. If it becomes true, then it executes these 4 printf statements. Afterwards Q++ will be done and I++ will be done here. Okay, so once the condition becomes false, then comes out, because this repeats 3 times based on number of employees. Okay, no need of checking I value here. Okay, so that's it. You will get all the employees details here. Okay, so you can print accordingly. Now you can just see here. This I need to close. Now I run down. So enter how many employees? 3 employees. Okay, so now you can see here A, B, C, or you can enter some names also. Okay, so just see here Ramesh, I am entering first employee. So age 35. Okay, and his salary 1234.50. Okay, then second employee. Okay, so Somaya I am entering. So his age is something like 40 and his salary is 6543.75. Okay, so then next employee details something like Ramaya I am entering. Okay, so his age is 45 and his salary is, okay, so 8765.70. Some 50 you can enter here. Okay, so now you can see there employees data. Okay, employee 1 details, name, age, salary, Ramesh 35. Then employee 2 details, Somaya. Employee 3 details, Ramaya 45 printed. Okay, so this way you can format the output in your own way. Clear? Okay, so this is an example program for a Clr function. Then altering the size of a block. For example, you allocated memory initially for 3 employees, and before closing the program, you want to reallocate the memory. Dynamic memory you want to modify. Then that can be done by using realloc function. Okay. So if we discover that the previously allocated memory, whatever memory we allocated previously is not enough, and we need some additional space for storing a more element, like 4 employees or 5 employees details I want to store immediately. Okay, or this is one case, or sometimes it is also possible that the memory allocated is larger than the necessary. You allocated memory for 20 employees, but you have only 10 employees. Okay, so then you want to reduce the size, either increase the dynamic memory or reduce the dynamic memory. Okay, so both is nothing but altering the size. Okay, so that can be done by using realloc function. So in these both cases, we can change the memory size already allocated. Okay, so already allocated memory size we can change with the help of a realloc function. Okay, so how it can be done, we'll see here. For example, if the original allocation is done by the statement, okay, so you have allocated by using malloc some size you have given and you allocated, and the memory is pointed by PTR. PTR is now pointing to that allocated size. Okay, now you want to modify this size. Okay, so then the reallocation of space may be done by using this realloc function in this way. Just see here, realloc. Okay, so reallocate PTR comma new size. Now you give new size as the second argument, and first allocated memory pointer you give here. Okay, so then what it will do, for the first allocated memory pointed by this PTR, then new size will be allocated there. Okay, and Again, this new allocated memory block will be again pointed by this PTR. Now PTR is set to the previous new one, newly allocated memory block. Okay, so previously you allocated 10 bytes. Assume that new size is 20 bytes. Then 20 bytes will be allocated. Okay, so it is nothing but for existing 10 bytes, another 10 bytes will be added. Another 10 bytes will be added, and same PTR will be pointing to that new block of memory. Okay, so I'll give an example diagram for this. Just see here. Okay, so now, for example, you have allocated a memory like this. Say PTR is equals to, okay, so I'm roughly writing here. So malloc of 10. Okay, so assume malloc of 10. So then what happens? Some 10 bytes of memory is allocated. Assume this is 10 bytes of memory. Okay, so then PTR is now pointing to this 10 bytes of memory. Assume now. Okay, so this is nothing but 10 bytes. 10 bytes of memory is allocated like this. Okay, so now you want to modify this to 20 bytes. Now what you can do is, now you can say realloc whose memory pointed by PTR. PTR pointing to some memory block. Okay, so that memory block you please reallocate. That is what we are informing. Okay, so to what extent we will need to reallocate? Reallocate to 20 bytes. Reallocate to 20 bytes. Okay, so then what happens means another 10 bytes will be added here. Another 10 bytes will be added here. Okay, so 10 bytes will be added. Total it becomes 20 bytes here. Okay, so already PTR has 10 bytes. So then remaining 10 bytes will be added. Extra 10 bytes will be added here, and this whole new block again will be pointed by PTR. No, so you have to say PTR. So what happens again? This realloc function modifies this memory and returns the pointer. You should catch in PTR. So PTR is previously pointing to this only 10 bytes. Okay, so new 10 bytes will be added to this, and you should make PTR. Why? Already you can ask, PTR is already pointing to this 10 bytes. No, sir, why we should make this PTR is equal to, already it is pointing. No, then now when it is pointing 10 bytes followed by 10 bytes, 20 bytes it becomes. No, so why we should say PTR is equal to, you may ask the question, because what happens internally means if 10 bytes after this is available, it immediately allocates 20 bytes at one place. Okay, assume that there are no 10 bytes of space immediately available after this first 10 bytes. Okay, so then what it will do is it identifies some 20 blocks of memory, 20 bytes of memory separately it allocates. Okay, so at some other place it identifies 20 bytes. 20 bytes it allocates. Okay, and whatever data is present in these 10 bytes, the data will be copied here. Okay, so the data will be copied here. The data will be copied here. Okay, so now this is another block of memory. Another block of memory, 20 bytes allocated here. Okay, so and the first byte address you should catch. No, so that's why when you say PTR is equals to, then now PTR will be pointing to this newly allocated 20 bytes. Okay, then what about this old 20 bytes? Now this PTR, the same PTR is coming here. Okay, or in other way I can show this. Now see here, so when you say PTR is equals to, so the same PTR is now pointing to this new block of memory. Okay, so that means now there is no link to this block of memory. There is no link to this block of memory. Okay, so nothing but now PTR is pointing to this new block, 20 bytes of memory. Okay, and this data is already copied here. So then there is no way of accessing this. Logically speaking, this entire memory is removed. Logically speaking, this entire memory is removed, and you will get an illusion that for the same 10 bytes, another 10 bytes are added, and then the entire memory is increased to 20 bytes. Okay, so that kind of illusion you will get, imagination you will get. Clear? So because your data is not lost here. Okay, so this may possible. Sometimes if 10 bytes are added immediately, 10 bytes will be added. If not added, not available, then 20 bytes it identifies 20 bytes free space, and all the data will be copied from there, and then this new block of memory will be pointed by this PTR. Okay, so sometimes if you print a PTR value before and after reallocation, then you can see sometimes a change in the address. Okay, right? Now this function allocates. Now see here, PTR is equal to realloc PTR comma new size if you give. Okay, so then what happens, just see here. So this function allocates a new memory space of size new size to the pointer variable PTR and returns a pointer to the first byte of the new memory block. So that's why you have to catch that in a PTR. The new size may be larger or smaller than the original size. Initially, if you give size is equal to 20 bytes you allocated. New size, if you say 10, then that 10 bytes will be reduced here. Okay, so either two ways you can specify the new size as increased size or new size as reduced size. Okay, so based on your new size, then the memory will be allocated. An example I am showing with the diagram here. Say P is equal to, for 5 integers I have allocated memory. Now assume that P is pointing to this block of memory allocated. Okay, so 2006 is first byte address. P will be pointing to this. Assume that I have stored some 5 numbers in this. Okay, so afterwards, now I want to store another 5 elements. Okay, so then what I do, I increase this size, realloc P comma 10 into size of int, 10 integers size I want to allocate now. Okay, so then this realloc, what it will do is, it allocates memory for 10 integers. Okay, so then the previous data will be copied first. The previous data will be copied first. Okay, so if the new memory is something at 3008, okay, so then now this PTR contains 3008, nothing but PTR is now pointing to this new block of memory. Okay, so you will get an illusion that for previous numbers 10 more or extra 5 elements data is added, because already previous 5 numbers are already there. Okay, so then another 5 elements extra memory is allocated. That kind of illusion we will get here. Okay, so whether these 5 elements are added after the same available memory or a new memory is new block of memory is allocated, that you can find out by printing the addresses. Previously the first byte address is 2006, now the first byte address is 3008. So when you print P afterwards, again if you get 2006, you can say that another 5 elements is added afterwards, appended to the existing one. If it is 3008, a separate memory for 10 elements is allocated and previous 5 elements are copied into that. Okay, so these are some higher level things. When you read these functions and pointers, then you can get more concepts. Okay, right. Now when PTR is pointing to this new block of memory, you can say that this old block of memory is gone. Okay, so now you will get an illusion that there is only 10 element space available. Now there is a program. Okay, so this you can practice program to store a character string in a block of memory space created by Malloc, and then modify the same to store a larger string. Okay, so using realloc you can do this. Initially hello you have stored, now hello world you want to store. Okay, so that can be done with the help of a program. You can use realloc function there. Okay, right. So this is about a dynamic memory allocation. Okay, so if you want this program, I can go through this program. let me stop the recording here.